Myself Dr. Vinodina from Department of Computer Science PG, Chris Jayanti College, Autonomous Bengaluru. In this discussion, we focus on how to split a decision tree for the classification problem with the Gini impurity measure, assuming a basic understanding of decision trees. As we know, the decision tree is one of the most widely used supervised learning algorithm. The goal of the algorithm is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. It makes decision by recursively splitting nodes into subnodes based on specific criteria. This process continues during training until the node becomes homogeneous or meet a stopping criterion. So, however, the recursive nature of the splitting can sometimes lead to overfitting. So, where the tree becomes too specific to the training data. So, hence node splitting is a critical aspect of decision tree construction and must be performed with utmost care to balance accuracy and generalization. Node splitting is nothing but divides a node into a multiple subnodes to create a relatively pure nodes. So what is pure nodes? We can say a node in a decision tree is 100% pure when all of its data belongs to a single class. So this is done by finding the best split for a node and can be done in multiple trees. So the way of splitting a node can be broadly divided into two categories based on the type of target variable. If the target variable is a continuous, then reduction in variance method can be applied, or if the target variable is a categorical variable, then Gini impurity, information gain or chi-square method can be applied. So in this diagram, the decision tree is constructed based on the split on the feature A and the feature B. The split on the feature A has the lower purity and the split on feature B has a higher purity. So this is decided based on Gini impurity measure. We will look at Gini impurity splitting method in detail. So Gini impurity is a method for splitting the nodes when the target variable is categorical, and this is the most popular and easiest way to split a decision tree based on the Gini impurity value. The Gini impurity value is calculated by 1 minus summation of I equal to 1 to n pi the whole squared. Where pi is the proportion of a class I in the data set and n is the total number of classes. So this Gini impurity calculates the degree of uncertainty or disorder in a node. Specifically, it represents the probability that a randomly chosen element would be incorrectly classified if it were randomly labeled according to the class distribution in the node. If all instances in a node belong to a single class, the Gini impurity is 0. For example, if all 10 samples are of class A, then Gini impurity would be 0. Now the steps to split a decision tree using Gini impurity. For each split, individually calculate the Gini impurity of each child node, then calculate the Gini impurity of each split as the weighted average Gini impurity of child nodes. Step 3 is select the split with the lowest value of Gini impurity and until you achieve homogeneous nodes, repeat the steps from 1 to 3. Let us see how to use Gini impurity in decision tree. Suppose we have a data set. With the two features: hour studied, attendance, and it is labeled as pass or fail. And if the target variable is here, it's a categorical variable, and we are trying to predict whether the student will pass or fail in an exam based on these two features: hour studied and attendance. Now, the first step is calculate the Gini impurity for the parent node. So, before splitting. So, the Gini impurity for the entire data set is calculated using the formula 1 minus summation of Pi the whole squared. Summation is from I equal to 1 to n, and Pi is the proportion of the each class whether pass or fail. In our data set, the classes are evenly distributed, that is 3 students passed and 3 students failed. So, the proportion of pass class is that is 3 by 6. 3 is the number of students in the pass class, and the 6 is the total number of students. So 3 by 6 equal to 0.5, and the proportion of fail class is also same, 3 by 6 equal to 0.5. Now the Gini measure for the parent node is equal to 1 minus 0.5 the whole squared plus 0.5 the whole squared. So we will get the value 0.5. So the Gini impurity for the parent node is 0.5. Now the step is to calculate the Gini impurity for each attribute slip. That is, we have to calculate the Gini impurity for the attribute hour studied and for the attribute attendance. Now based on hour studied, the Gini attribute calculation is given in the slide. Suppose we are splitting the data set based on the attribute hour studied equal to 3.5. Then we will get 2 groups. So the group 1 is hour studied less than or equal to 3.5. The other group would be the number of hours studied greater than 3.5. Then in each group, so 3 students, 3 samples will fall. Pass category, 3 that is in group 1, no students. Then fail group, we have 3 students. That is, if the study hours is less than 3.5, then the data would be come under the category of fail. Then for Gini group 2, that is the hour studied, if the number of hours studied is greater than 3.5, then the number of samples would fall into the group would be, pass group would be 3 and the fail sample would be 0. So for both the groups, the Gini impurity would be 0. So next we calculate the weighted Gini impurity for the split based on the size of the each group. So that is equal to 3 by 6 into 0 plus 3 by 6 into 0 equal to 0, because for each group the Gini impurity would be 0. When we calculate the weighted Gini, it should be the number of instances in the group divided by total number of samples into Gini impurity. So we will get the value 0. Next we will calculate the Gini impurity for the attribute attendance. Suppose we split the data set based on the attribute attendance, based on the attendance 75%. So we will get 2 groups. So one is less than or equal to 75%, other equal to greater than 75%. So we will get the 2 Gini group. So the Gini impurity for the first group, that is attendance percentage less than or equal to 75%, we get 0.45, because one student we have 1 instance fall into the pass group, 2 instances fall into fail group. For Gini group 2, that is attendance greater than 75%, in the pass group we have 2 samples, and in the fail group we have 1 samples. So for the Gini impurity for both the group would be same, that is 0.45. Now the weighted Gini impurity would be 3 by 6 into 0.45 plus 3 by 6 into 0.5 equal to 0.45. That is for Gini impurity value for both the group is same. So we will get the weighted Gini impurity 0.45. The next step would be compare the Gini impurities. So Gini impurity based on hour studies is 0. And Gini impurity based on attendance is 0.45. So as per the concept, the node which would have Gini impurity less value would be chosen for further split. So however, the decision tree will choose hour studied as the first attribute to split the data set, because it gives the value 0. Okay, because hour studied result in purer groups than splitting on attendance. So a Gini impurity 0 means that all the elements in a node belong to a single class. That is, the node is pure. The higher the Gini impurity, the more mixed the classes are within the node. So now using this decision tree construction, we have to classify the new data point. Suppose we have a data point with hour studied equal to 2 and attendance percentage 85%, then the model easily would classify the data as the students fail. From this, so we can understand that it is very simple to identify or select the feature to split the data set, which is mainly used for creating the model. Thank you.